Lesson 6.2, Types of Energy. Energy is the ability to do work. Kinetic energy is the energy due to motion. Oh, but how does just motion have the ability to do work? Well, if something in motion hits an object, it's probably going to put a force on it and often move it a distance. Just think of you being run into by a very large person. It would force you back some distance. That's work. So just being in motion gives you energy or the ability to do some work. Kinetic energy is 1/2 mv squared. Like work, energy is scalar. No vectors, no directions. And its unit is a joule. When something is rotating, it's moving, and also has kinetic energy, which would be 1/2 I omega squared, where I is the moment of inertia and omega is the angular velocity. Refer back to your previous notes to find the formulas for the moment of inertia. Another type of energy is potential energy, which is the energy due to position. Usually we consider it the energy due to position as in gravitational potential energy, energy due to gravity. But it could be a stretched spring or other things like that. If work is force times distance, for gravity, the force of gravity is mg, so the work for gravity is mgh. So our potential energy due to gravity is mgh, mass times acceleration due to gravity times the height. Since the force of gravity is down, we only worry about the vertical distance. And potential energy is not absolute. It's always a difference, because where's the height 0? Do you set the 0 height as being on the ground, or the 0 height or where it started, or is the 0 height somewhere else? The path the object takes doesn't matter. It's just the vertical distance. So we can go like that, but we only care about the vertical distance that it fell between the starting and ending height. Our height is measured from any chosen point. I could say height 0 at the bottom, which is the most common. Or I could say height 0 at the top. Or I could pick some random place in between and say the height is 0. If I do that, then I'd have a positive height above it and a negative height below it. Just pick any place and just be consistent and say that is 0 height. We also have potential energy due to springs. If work is force times distance, and the force of a spring was kx, or our distance is x, but it requires calculus to properly calculate the work because the size of the force changes with the distance. When that happens, we have to do some calculus, and the answer is 1/2 kx squared, where x is our distance. So that's the potential energy for a spring. A 5.2 kilogram Canada goose is flying towards you at 18 meters per second and a height of 3 meters. What is its kinetic energy and potential energy? Well, kinetic energy is 1/2 mv squared. The mass is 5.2 kilograms, and its velocity is 18 meters per second. We'll run that through the calculator, and you get 840 joules. So it has 840 joules of energy just because it's moving at 18 meters per second. The potential energy will be gravitational potential energy, so mgh. The mass is 5.2 kilograms. G is 9.8 meters per second squared. And the height above the ground, I'm going to call the ground 0. So the height would be 3 meters. Run that through the calculator and you get 150 joules. So this goose has energy because it's moving, and because it's above the ground, and could fall down and squish you. Let's say a coil suspension spring on a car is compressed 9 centimeters after it's installed in a car. The spring has a constant of 33,000 newtons per meter. What is the potential energy stored in the spring? Now, this is very important because if they break while you're working on it, you can be seriously hurt by a coil spring that's compressed for a car. So potential energy for a spring is 1/2 kx squared. K is the spring constant, 33,000 newtons per meter. And we're compressing it 9 centimeters. Well, 9 centimeters, if we convert that, there are 10 to the negative 2 meters in 1 centimeter. So that'd be 0.09 meters squared. Multiply that out, you get 130 joules of energy.